So to start with simplifying expressions, I would like to review a couple properties. Uh-oh, my pen stopped working. My whole iPad just froze. There it goes. Okay. Commutative property and the associative property. You guys have probably heard these before, right? You guys have heard the commutative and associative properties. So these only work for addition and multiplication. However, though, Tandon, we did talk about how we can view a subtraction as a negative. Then you could use negatives in this too, as long as you view subtraction as a negative.
Yeah.
Okay. So the way I remember these is by the language. So to commute, or if someone is a commuter, what does that mean? Just by language, not even math, like a commuter. A commuter train. There's a commuter train that goes to Chicago.
Oh, then they're traveling.
They travel, they move, right? So commutative property, I like to just show, it's the same thing as, my iPad's struggling today for some reason. One sec, guys. 3 plus 2 is the same thing as 2 plus 3. That's the commutative property. If I move the terms, it doesn't change the answer for addition, correct? It also doesn't change it for subtraction if you keep your symbol with your term. Okay? Right? If I keep my 2 negative. Now, the associative property, what does it mean to associate with somebody, or this is my associate?
You're involved.
It's part of your group, right?
Yeah.
So the associative property means something like 3... I apologize again. My iPad's glitching out. 1 second. Let's let it catch back up. This is going to be the most engaging YouTube video ever at this point. Okay, 3 times 2 times 4 would be the same thing as 3 times 2 times 4. If I change the grouping, it doesn't change the answer, if it's all multiplication or all addition. So the associative property says if you change your grouping, it doesn't change the answer. I like to summarize these properties as, if it's all addition or if it's all multiplication, order doesn't matter. Do what you want, right? To make things easy. Like, if I have 12 plus 5 plus 8, what might be nice to throw together?
12 and 8.
Yeah, because it makes 20, right? That's commutative and associative property at work there, right? Look for ways to make things easier. You don't always have to just go left to right if it's all addition or all multiplication.
But what about the distributive property where it's like if you have 31 and 19?
Well, let's talk about that. Distributive property. That was the plan to come next. Distributive property.
You know, we usually should be impressed if you scored a basket on.
So the distributive property really is, do you remember yesterday we did those emergency kits for the zombie thing? And there's like 5 of them, and let's say we have 4 waters, and we'll just do 1 machete. Okay? I know there's more stuff in there, but if there's 5 of them, you guys naturally multiply it to get 20 waters and 5 machetes, right? That's the distributive property at work. Your emergency kits from the zombie thing yesterday. Now, where it gets really cool with distributive property is this. You can do a lot of mental math, and I've already been teaching you some of it. Would you guys agree that this problem is the same thing as this problem?
Yeah. I can't see that.
Yeah. In the parentheses, I have a 47, right? Well, if I have 6 groups of 40 and 7, I can do 6 times 40, and I can do 6 times 7, and get a 282 pretty nice. So I don't actually break it up like that. Like, that's not exactly what I see in my head. I just see a 40 and a 7. But that's the idea. That's the distributive property to show how to do some mental math. Now there's another way we can do this that's pretty cool. Let's say I had a 6 times 49. Another way to write 49 would be 50 minus 1. And you might want to do this because 6 times 50 is kind of nice. Right?
6.
So 6 times 50 would be 300, and 6 times the negative 1 would be negative 6 for 294. So I don't know if you've seen me or other math teachers do some like math that looks kind of crazy, but they do it real fast. They're doing stuff like this. It's called deconstruction and reconstruction. Use things like tens, hundreds, numbers that work nice together, and we use these properties to do that. It's not like, not many people are walking around with 6 times 49 just memorized. Somebody might, but not that many people, right? Well, I know when I see 6 times 49, I see a 240 and a 54 and get 294. Like, with practice, right? With practice. So let's practice a little distributive property, how you might see it. Actually, first I would like to make sure we all know what a like term is.
Wait, how long have you been teaching
Here? It's my 11th year. Like terms.
in your class?
Who?
Damien?
Yeah. Okay,
He's a great
so like terms. 2 things to make something like terms. It was pretty easy in the zombie thing because, like, we put blankets with blankets, spoons with spoons, rice with rice. It made sense, right?
Yes, sir.
We didn't put spoons in blankets and make splankets. Remember? We didn't do that. So, to make a like term algebraically, 2 criteria. They have to have the same variable or lack of variable, right? Like 5. I think you guys already know, like 6, -4, 1/2. Those you can just add and do stuff. We also need the same exponent. Same variable, same exponent to be the same type of term. We can only combine like terms. Again, we can't have spoons and blankets making splankets. It'd be cool. Maybe I'd go on Shark Tank if I could figure it out. Eat your soup and stay warm at the same time. Cleaning would be an issue, but it could be cool, all right? But it doesn't work. So let me give you some examples of things that are like terms, and then I'll give you some non-examples, all right? You ready? So some examples of like terms would be like x, -2x, 1/3 x. All of these have variable x to the first power, correct? Okay? Here's a non-example. 6x squared 4. The one that would not fit is the x squared. It has a variable x and an exponent of 2. I could combine the 4 and 6, but the x squared I could not combine. All right, I'll give you another
Wait, what is that one? Oh, is that
x squared. I just crossed out saying that's not like the other ones. Okay, let's look at 6. Uh-oh, my iPad's doing that freeze thing again. 6x, 2x squared, -2x. This x squared, you could not combine with it. It's something else. Okay? So to be a like term, same variable, same exponent. I'm going to give you one more. Let's say we had a 3x squared y, 1/4 x squared y. Those are like terms. They both have an x squared y. But if I had xy squared, that one would not be a like term. It does not have the same variable and exponent, right? The x would have to be squared and the y would have to be to the first. So just thinking back to the zombies, we could put the rice with the rice, the water with the water, right? We didn't mix things. Same thing happens algebraically. We can only combine the terms that are like terms. So I wanted to look at a couple algebraic examples with you with this. You might be able to be asked to do something like this. I got -10 times 5n minus 10. All right, so thinking back to the zombies, those emergency kits, what did you naturally do knowing that you had 5 kits?
multiplied?
You multiplied everything by 5, right? Same thing here. I've got -10 of everything in the parentheses. So that's a -50n plus 100. All right? So we're using the distributive property here. We know we have -10 of everything in the parentheses. And what's nice is, this is a little simpler. It's a little easier to understand, right? When those emergency kits, you didn't know how many water bottles you needed total of emergency kits until you distributed. We're only going to do one more of these guys before we practice on Kahoot. You ready for some next level stuff here?
Yes, sir. Ski.
Let's level up. So, let's try one that's a little tougher. Looks like there's more going on here, right? Just a little bit. And I'm hoping that you're seeing the distributive property pop when you see this. I have some parentheses with things multiplied. Also, I also want to make sure you guys know some terminology. You know the number in front of the variable? Like, I'm trying to draw. That number is called the coefficient. Have you heard that before? The number in front of, so if I'm ever talking, you hear me say coefficient, that's what that means. Anyway, we're going to multiply with the distributive property here, and we're going to rewrite everything. So 4 times x would be 4x. 4 times 9 is 36. 5x times 3 is 15x. And 5x times the negative 2 is negative 10x. So what I did is I distributed my 4 to my x plus 9, and I distributed my 5x to my 3 minus 2. All right? We're not done, but do you follow what I did, everybody? Thumbs up? Okay. So now I have like terms. I can only combine like terms. I can't combine everything. And I don't know if you remember from that little warm-up, but I like to underline the things that are alike. So do you notice how I have one line under all my x to the first powers? I can combine all those. This 36 has to stay lonely. There's no like term with a 36 that can't be combined with anything. So as I combine these, 4 and 15 makes 19, and then minus 10x, 9,
It'd be 1 x, right?
9x. I got 4, 19,
Oh shoot, that's a 10.
minus 10, yep, 9x, and then my plus 36 has to stay plus 36. Now let me give you a pro tip on a test, okay? There's a way you can check your answer. Do you know, who can tell me what should be true about the value of this and the value of this? I haven't changed the value, I've just changed the way it looked. So if you on a test want to just be like, okay, x equals 3, and you plug it into both, you should get the same simplified answer as a number if you did it right. Does that make sense? We haven't changed value, we just changed looks. So the value's the same. So if you substitute something in for x, the same thing in x for both, it should pump out the same number if you did it right. All right? So just a check. It'd be like cumbersome to do that over and over on a homework, but for a test where the stakes are higher, not a bad idea. So that's the distributive property. That's like terms. You're going to be using this stuff forever in math now. In algebra, advanced algebra, geometry, you're going to be using this stuff forever. We use coefficients with variables a lot for like ratios of things, like this side to this side to this side of a triangle and such. So it's not going to go away anytime soon.